Hi, this is Maxine Spencer, and this is my Lab 1 on charge tapes for Physics 2. So this lab focuses on the exploration of interactions between two strips of charge tape. So we determine their charges with our experiment, and then we model them in a simulation in GlowScript. So for physics principles, these include electrostatic attraction and electrostatic force. And a quick overview of my results is that 1.9799 e to the 8 coulombs was the charge, and this charge was positive. So a few principles are the electrostatic force equation, which is that force equals kq1 q2 divided by distance squared, distance being, of course, the distance between the two charges, and the force of gravity when well within the atmosphere, which is force equals mg, and g equals negative 9.8. Then electron and proton charge, which is that proton is 1.602 times 10 to the negative 19 coulombs, and the electron is the same, but negative, so negative 1.602 times 10 to the negative 16 coulombs. For the experimental setup, two functionally identical tapes were used to simulate the charge. So the same type of tape, same dimensions, etc., etc. And so the same charge is assumed afterwards. It's used as a point charge due to even spread across the tape. So they were held parallel and with hopefully no hand interference. Photo 1 here is the initial position before the repelling began, and the photo 2 is the final position when it had gone as far as up as it was going to. In terms of initial observations, the tapes appeared to have positive charges, charges, and so they attracted to pen when rubbed on shirt, and they repelled from each other. Those are both shown here. This is the attraction of the pen, and this is the point of about 2 centimeters apart where they started to repel each other. So getting to the numbers, the net force is 0 because the tape floats. So Fe equals negative Fg. The tape weighs 1 gram per meter, and the tape length in our experiment was 0.3 meters. However, the mass was listed as 0.004 kilograms, since the initial length of the tape pre-folding was 0.4 meters. And that might be a source of error, because we probably should have still weighed it based on the length, since those other parts were being held. But anyway, the width of the tape was 1.9 centimeters. So here's the code. We've got my mass, my length, my distance, and my gravitational acceleration. We've got the constant 90 to the 9. We've got the charge of a proton and the charge of an electron. We've got my two tapes. We've got the force due to gravity. We've got the charge that we found, and we've got the force to electricity. And this is all of that printed out. So some points of potential error. I think that the tape could have lost some charge to the hands of the environment, and I don't think it was 100% parallel to the other tape. We did measure the mass before folding, so it doesn't match up with the length perfectly, and the tape likely was not a point charge because inconsistencies were probably present in the force of the upper and lower tape being ripped. So what if the electrons had a positive charge, the protons had a negative charge? What would change in these observations? There wouldn't be any change, really. They'd just both be negative, meaning they'd repel each other. So I guess the one difference could be the repelling the pen when we tested that to see if it was positive or negative. But for the actual important result, there wouldn't be anything different because they would just repel each other still. And so is it important to handle them as little as possible? And what happens if you're not careful and the contact occurs? It's definitely important because the electrons from your hands or other objects can move onto the tape, and this will effectively neutralize it and make it not repel as well, and invalidate your results. So in conclusion, the model seemed accurate, save for the fact that I think I had errors with the masses, and any human error didn't seem to mess stuff up all that much. And the tapes can experimentally be viewed as point charges, even if that isn't 100% perfectly accurate. Alright, thank you.